We begin with adding two measurements. We measured the speed of a ball moving on a train using a motion detector and found it to be 12.3 plus or minus 0.1 meters per second. We also measured the speed of the train using a radar gun and found it to be 23.40 plus or minus 0.05 meters per second. Since they are both moving in the same direction, we want to find the combined speed of the ball and the train, or in other words, the speed of the ball that a stationary observer would measure. The first step is to calculate the combined speed. This takes the total speed is the sum of the ball speed and the train speed. We add the measurement and find it's 35.70 meters per second. We do not know how many digits to keep at this point, so we'll keep all we have and round off after we have calculated the uncertainty. This number is our total speed measurand. Now we calculate the uncertainty for the sum. The way to do this is to add the sum of the squares, like this. Note that because we are squaring both uncertainties, the final uncertainty will always be bigger than any of the uncertainties in the sum. In our example, we square both uncertainties, add the squares, and then take the square root. We get a combined uncertainty of 0.1118 meters per second. We can now round to two significant figures and then adjust the number of digits in our measurand to match. That gives us a total speed of 35.70 plus or minus 0.11 meters per second. Both measurements were made using a 95% confidence interval, so our final measurement is also a 95% CI. Finally, since we are reporting a calculated quantity and not a measurement, we do not have a probability distribution function to report. So the final measurement report is y total is equal to 35.70 plus or minus 0.11 meters per second, 95% CI. In general, when we add two quantities with uncertainties, we can use a general form. If the measured quantity is x plus or minus the uncertainty in x, y plus or minus the uncertainty y, and so forth, to z plus or minus the uncertainty in z, are used to compute a result r, which has the form r is equal to a times x plus b times y plus as many terms as you're adding together, plus c times z plus d, where a, b, c, and so forth, up to d, are constants with no uncertainty, such as 2 or minus 1, which is how we subtract two measurements. X minus y is the same as x plus minus 1 times y. Then the uncertainty in r is given by the square root of the sum of the squares, where we multiply each uncertainty by the same constant as we did to calculate the measurand. Make sure that all uncertainties are 95% CIs, and that they are random and uncorrelated. That is, they do not have any connection to each other. So the steps for calculating the uncertainty for the sum of measurements is to 1. Calculate the result measurand using the measurands of your measurements. 2. Add the sum of the squares of the uncertainties times any constants and take the square root. 3. Adjust the digits of the uncertainty and measurand to fit our conventions. And 4. Report the final calculation.